Okay, so picking up where we left off, section 11.2, part 2 of the video here, and we had just talked about the velocity vector, so that would have been cosine 6, comma 6 for the velocity vector at time 6. Acceleration vector, moving on to acceleration vector, I would have a of 6, put a bar over top that to indicate it's a vector, and I'm going to look back up here where we had already taken the derivative from velocity, so I'd have negative sine of 6 comma 1, and that would be our acceleration vector. If we wanted to describe the motion of the vector, I'm going to use my knowledge about velocity vectors, not velocity vectors, but just velocity on a linear motion, and when that was positive, as it is here, this would indicate that I had right-hand movement. So it was moving to the right. I'm going to go x prime of t was a positive. That indicates we had right movement. Y prime of t in this case turned out to be positive. I guess we could put 6's in here, couldn't we? And that indicates that we have upward movement as well. So our particle's moving to the right and up. Next, let's talk about displacement and distance traveled. Displacement is defined using integrals. No big surprise there. When we had linear motion, we did the integral of the velocity function. So now we'll just do two integrations, one for the x component and one for the y component, and it will be a vector value when we come out. So displacement is going to be two values. We will have x displacement as well as y displacement. So those will be two values, just like velocity vectors have two values and acceleration vector has two values. Distance traveled is going to be one value, and as you can see from the definition here, it looks very similar to what we've had before, where we have the integral from a to b of the absolute value of velocity, and this will be talking about the magnitude of our vector, and that is nothing more than arc length. So one easy way to figure out the total distance covered is to calculate the arc length that the particle moves on. So let's find displacement and position and all the fun things. A particle moves in a plane with velocity vector. The velocity vector is given, and at time t we know where the particle is starting, so here's our starting point or our initial position. In order to find the position of a particle at time 4, we're going to find our ending position at time 4 by looking at where the particle started, adding with it the amount of movement or the displacement, so the accumulation from 0 to 4 or the displacement. So just writing out the word displacement so I could think of where I started plus the displacement of the particle. Our ending position for x, will be x of 4, will be, where did I start? I started at 1, add with it the amount of displacement from 0 to 4 of the velocity vector, so v of t, with respect to x dt. Or we could have this 1 plus the integral from 0 to 4 of p minus 3 pi cosine pi t. And in this particular one, you would maybe want to set up u to be pi t, but I think most of us can see that du is going to be pi dt, and we'll have a correction factor of 1 over pi du equals dt. If you integrate that either by hand or through the calculator, you will come up with a value of 8. So my displacement is 8. I started at 1. My final position is going to be 9. The final position in the y direction, y of 4, will be where I started, which is 5. Add to that our displacement, 0, 4, velocity vector with respect to of the velocity vector y component, dt, is equal to where we started, which was 5, added to it the displacement in the y direction from 0 to 4, and that would be what? 2t minus pi sine of pi t times differential t. And that'll be 1 plus, if you do the calculation on this one, it will turn out to be 16. And, oops, I'm sorry, 5 plus 16 gives us 21. So my ending position would be the vector 9, 16. My displacement vector, the displacement would be the 8, 16 values. So that would be displacement. This would be ending position. What is the total distance traveled by the particle from time 0 to 4? That really is nothing more than arc length, and arc length is calculated from 0 to 4 square root x prime of t quantity squared plus y prime of t quantity squared dt. I did not get a value on that, so if you want to, go ahead and put it in your calculator and get your value. But I know you can do that. That's just arc length. And you have, for an assignment, my math lab 11-2 vectors day 2. I have 12 problems for you. If you get stuck, do view an example, and that should help as well.